it's interesting to think about it in that we're talking about ecological reparations that definitely refer to the organisms that are living within these environments that these groundwater aquifers that provide what we often think of as just resource drinking water, but that's part of a much larger ecosystem, and there's a whole bunch, a multitude of organisms, communities that are involved in sort of stewarding that water or managing, taking care of that water in their system. And so there's a lot of damage, obviously, that has gone on with destruction or degradation of these. So it's I think it's very relevant there in rethinking how we interact with and manage um, groundwater. But it also is extremely relevant to the communities of people who rely on those sources of water for drinking water as well. They are often not the ones responsible for contaminating the water. They're kind of caught in the crossfire. They're living in places where very poor management is going on, or very irrational or irresponsible waste disposals is going on. So they're not living in the same place with the organisms below ground that are engaged in, that very much create and maintain the quality of the water that we're pulling out of these ecosystems below ground. People aren't living with them, but they're intimately related with them, but in ways that a lot of people don't understand that those relations are even there. So there's a lot to learn about that interconnection, and I think that's part of what reparation means is considering all of us, the humans and the more than humans involved.
For us, your understanding of remediation and has this ecological dimension that embeds that act of repair at the heart of a multitude, as you just said, of relations, rather than as a techno fix where we come and just fix something that.
Remediation, which is to bring a remedy to, it's like a fixing, but it's to make better something that is not as good, like in a health context, to remedy something. And it's a word that is, been very much adopted by engineers, and it's part of their vocabulary in what is, I think, a very, techno-fixy kind of approach. But the word has more meaning, I think, also than that. But a word that I like to think about is a word that's increasingly popular in agriculture, which is regeneration. So to regenerate ecosystems, and that means that means to bring them. To me, that implies there's life there. Remediation implies there's a problem there that needs to be remedied. But regeneration means, I think that it has to have life for something to be regenerated. Regeneration is about looking at the whole system and the health of the whole system below ground in these groundwater aquifers, and what are all the things that we need to think about and address to bring them back to a place where they're to deal with the insults of the ravages of the contamination and what that might have done to them, but also helping them deal with the contamination, because they have a lot of capacity to biodegrade, right, to clean up themselves the contamination. There's this beautiful word depuration that's often used, depuration in human bodies, which means to get rid of impurities. And like in our bodies, our liver acts like, works to deal with toxins in our body, to get rid of impurities. And that's what the microbes are doing in the aquifer. They are like the liver, not just in one place, scattered throughout the aquifer. Well, groundwater exists in aquifers. Aquifers are a name geologists gave to this area, deep in the ground that's like rocks, porous material that is filled with water. And I think for a long time people said groundwater is sterile. It can't have life. But we know now it has a lot of life. And it's maybe some plants, some tiny animals, but particularly microorganisms. And they're thriving. They're like energy, and materials are flowing through them. They have all sorts of interactions with each other. They're competing, they're preying on each other, they're cooperating, they're living on mainly the surfaces of the material and of the solids in the groundwater, and then the water sort of flows across them because the water's always moving in the groundwater. So there's a huge variety of different amazing lifestyles down there that is reflecting this enormous diversity and the preciousnness, right, of these systems that people don't think have life, right? And we have a tradition historically of like when we have toxic waste, like industry, oh dear, we don't need this anymore. It's dangerous. We've got to get out of the way. Oh wait, we'll put it in a barrel and we'll bury it. We'll bury it in the soil. And of course, the container corrodes over time, and the toxic materials then start migrating downward to groundwater. We also in agriculture apply pesticides and fertilizer everywhere. Gas in your gas tank, they just accumulate and create these big plumes of contaminants moving in the groundwater. And like most gas stations they have contaminated plumes around them, right? So all this stuff that we do above ground, and then sometimes intentionally or maybe unintentionally interacting with waste, they find their way down to these aquifers, to this groundwater. So what do engineers do? They may pump the water out to a reactor on the surface and clean it there. But what's amazing is that the chemicals, you get the water, the stuff that's in the water, but most of the contaminant is stuck to the surfaces of the porous media. So as soon as you clean out the water, a few years later, it's just as contaminated as before. It works sometimes. It works to satisfy the regulatory pressure on the party of interest, or the perpetrator who made the spill. They need to hire the engineers. They need to get in there in a few years, just like pump stuff out. They can probably show that the concentration is now okay if they look at the water because it meets the regulatory guideline. But a few years later, often it's just right back up to what it was, but it satisfies the moment. So what is another way? What's a regenerative way? Where is it contaminated? You can look at chemistry. You can look at, there's the concentration of the pollutant. But you can also look at changes in the communities down there. Because if it's polluted, like a lot of times they're going to shift over to organisms that are more resistant. And we're going to lose organisms that are sensitive. So you can see these sort of characteristically different communities, both with the microbes, but also with the invertebrates, these tiny invertebrates that live down there. Other things you can do, though, is just let it be. It's interesting. It's called passive remediation. It's monitoring. It's sort of letting the system go, but monitoring like areas where that contamination might be moving. Because remember, it's always moving, where it might be starting to hit a groundwater aquifer. Now some people think this is a do nothing. They like the tar balls will get encapsulated in like sand and gravel. There'll be these little, they're kind of like protected against oozing out and getting more into the biological system. Sometimes people feel it's better to just let that be than go in there with solvents and blast it all up and try to get it dispersed and then try to suck it up, but then a lot of it goes all over the place and kills. Well, especially if you use solvents to spray it down, you can wipe out a beach for decades. You can just sterilize it, by using these technologies to clean it up. By cleaning it up, you make it, you have other impacts that are very damaging. So it's interesting to think about how humans and other than humans can be brought together around this concept of ecological reparations and how they can interact with one another. And communities in, for example, the Central Valley of California that are living with contaminated water are also living with contaminated air. With air, you can monitor it fairly easily and know what the impact is to you. That can be done by community members so that they're empowered. They're not going to just hear it from some outside source that they may not necessarily trust or that may be, not up to date. But they can't really control the contamination of the air, because it's usually coming from further away and it's more diffuse. It's interesting to think about groundwater because there, I think there's also the capacity for them to be able to monitor their own groundwater. Not for everything. Some of the tests are really complicated. Some of them are easier. But that would be a first start is to understand like what is the condition of their water. They could engage in interactions with the below ground life there. And are there ways that some of these tests are simple and they could use them and learn who's there and get introduced to one another and perhaps it could move into looking at what is the potential for there to be some regeneration of these communities as well, and some of the interventions to try to help do these regenerations. If you've got shallow groundwater, are things that probably people could do, like add oxygen. So I think there is potential, and a lot of it may be more about the connection and just having that sense of connectivity. And here is part of your world that is below you, below it, not in sight, but there it's like imagination has to come, and it's just new futures, right? Other futures. Where might that lead?